So we're going to take one last stab at converting a polar equation to a Cartesian form. And we can notice from the graph of this thing that this is not going to be a standard easy equation that we're going to know and love. All right, so r is equal to sine of 2 theta. Now that sets off little bells in my head because sine of 2 theta, we have a identity for that. Sine of 2 theta is a double angle identity right here. So the double angle formula says that it is 2 sine of theta cosine of theta. Thank you to the trig cheat sheet. Okay, so that means that I can know that this is equal to 2 sine of theta cosine of theta because of the double angle identity. Gotta love that pre-calc. Now we're going to do a little bit of trickery. We love it when we get tricky. So let's recall. No, I'll just leave it like that. X is equal to r cosine theta. Doesn't that mean that the cosine of theta is equal to x over r? So that means that this guy right here could be written as x over r. Interesting. You know what I'm about to do, right? The same thing for y. So y is equal to r sine of theta, but that means that sine of theta must be y divided by r. I'm so sneaky. Okay, so r is equal to that. That means r is equal to 2xy divided by r squared. But r squared is equal to x squared plus y squared. So I really need to change the color of this recall because it's not just the green part. It's all of it that's getting recalled. All right, so x squared plus y squared. So that r squared right there, I could rewrite that. I could say that's really 2xy divided by x squared plus y squared. Okay, we're getting there. We're getting there. We got a lot of x's and y's, but I still have this r. Well, r squared is x squared plus y squared. So if I just square everything on both sides of this, that would work, right? So if I go squared, squared, I can do that. That would give me r squared is equal to 4x squared y squared over x squared plus y squared squared. But I know r squared is x squared plus y squared. So that would be x squared plus y squared is equal to 4x squared y squared. Okay, well, why don't I just multiply both sides by that x squared plus y squared part that's in the denominator? I don't want a denominator in any of this. So if I do it over here, then I'll do it over here as well, of course. No good place to write it. So it's x squared plus y squared squared. So there's x squared plus y squared squared, and there's another one, which means I'm going to have x squared plus y squared cubed equals 4x squared y squared. That's it. You've got an equation, right? It cannot be solved explicitly for y. Oops, something. So just leave it. I mean, technically we could have left it right up here, but it wasn't as nice. It had that denominator in it, so I didn't feel like it. All right, so let's double check and verify that my equation will work. Oop, I went too big. Hold on. All right, so r is equal to 2, or sine of 2 theta is that lovely petal picture. And then that blue part is the Cartesian graph. Now you'll notice Desmos actually does a terrible job right in there in that vertical part and that horizontal part. And that's because it's getting so close to not being a function, right? That Desmos doesn't handle that very well. The polar graph doesn't have that problem. The values are actually there. It's just Desmos isn't drawing them very well. That's all. If I zoom in, I can see it starts drawing them better and better, right? But when I zoom out, it doesn't show them. It shows like a little gap in there. But if I draw the polar graph, that's not a problem.